Jupiter, Saturn, and the Moon. Like, things are happening. Hong Kong is picking up again. It's been a tough 3 years. I live here. I actually live in Hong Kong. Actually, I was born in Hong Kong, but that's another story. So, we ran a lot of these communities like Hyperledger. We had these monthly meetups. We had these great things, and I think it's been very, very challenging during this period. So this is now a kickoff again. Today we're going to have the first inaugural meetup for the Open Source Security Foundation, which is very exciting. And I'm also very, very excited that we have Brian Behlendorf here, right? Brian, yes, I think we're here on the back. I think the last time you were here was 2019, so that's 3-4 years. So Brian's going to give us an overview, and then we're going to have a few other talks as well. As part of this kind of community, OpenSSF is relatively new, would you say that, as a project? And actually, we were just starting the meetups, and I think Hong Kong's probably the second meetup that we've done, kind of globally. So we're really kicking off things here. Not that there's been a lot of activity happening, and you're going to hear that all from Brian. I have worked, since we knew Brian was coming, we worked on our meetup, and I have been very lucky to have some people, organizers, to help me, and I'd like to introduce them. So we've got Zhang from Google. We've got Boris from AWS. There's a pattern there, so some cloud providers. And we have Harris. There's Harris. Harris here from IBM, who's our host today. So thank you so much. I'm now going to hand over to Brian. I don't know if anyone, I thought everyone knows Brian. He was the founder of the Apache Foundation. He was a CTO of the World Economic Forum. For the last 6 years,
World Economic Forum, there you go.
Yeah.
Censorship.
Yes, it's back. So obviously I can't talk about that. No, he was the CTO of the World Economic Forum. He helped Hyperledger. I think we all know Hyperledger for the last 6 years, and now he's moved on to OpenSSF, and he actually did the first ever banner ad on the internet, right? Way back. So it's all his fault. Anyway, with that, I'll pass you over to Brian. He'll give you an overview on OpenSSF. Thank you.
So I'm going to try to just give you a little bit of sense of context for the challenge that the Open Source Security Foundation is trying to address, and then a little bit of a sense for who we are as an organization today. But really, I want to pull all of you in as collaborators, not only to use some of the stuff that's coming out of OpenSSF in your own organizations, to help you make the case to your bosses for why you should be allowed to do this work and allowed to invest into improving the security of the applications you build and the stuff you depend upon. And really just how do we all, I mean, it was funny when Log4j came out, it kind of crystallized so much of what we were already working on and helped us make it easier to explain even to policymakers and folks in the White House. We're here to try to reduce the risk of the next one happening, and if it does, because it will, there will be another bug like the Log4Shell kind of vulnerability. When the next one hits, how do we keep it from ruining everybody's winter break like it did about 1.5 years ago? As I'm sure it did for many of you. So let me just start with that as the context. Now, there's this term, the software supply chain, which makes it sound like a very formal kind of, integrated system. We know that open source software has become critical to the software systems of the world. And this wasn't by necessarily a top-down plan for world domination, despite what some people might have told you. This was a very organic, bottoms-up, developer-driven movement to go and pull in code that seemed to work well enough and was the right price, but also came with a lot of freedoms that now we all can take for granted. 25 years ago, and Julian was working for Sun Microsystems, and we had a lot of commercial software infrastructure. Open source and Linux and other things were much more the insurgent. Now open source has become the default. 70 to 90%, depending on the studies you look at, of commercial software, of the software that's running inside of your phone, inside of your Tesla or other car, behind a website, 70 to 90% of that is pre-existing open source code. And yet open source was kind of developed in a high trust environment where we could kind of take for granted that if you found a piece of software on a website like Apache.org, that there was probably a bit of diligence and care taken to its development. It was probably built by developers who, had the interests of their users in mind, and cared about the security of the system. Now we've got hundreds of thousands to millions of commonly used open source packages out there. I think GitHub is up to 100 million different repos or more. There's a lot of noise out there, and frankly, the assumptions we've made about the suitability of open source as critical infrastructure, really we have to think twice about that. So, and even the concept of the software supply chain has gotten a lot more complicated than when I got started, where you pull a tarball down, you do make install, and suddenly you've got a mail server running or a DNS daemon or something like that. Instead, we have these CI/CD processes that pull in dependencies, pull in configuration files, pull in a lot of data from lots of different places, and more importantly, involve lots more people in the path from software source code in some developer's head to production system creating value. And along the way, we've created opportunities for new kinds of vulnerabilities to emerge. For code to get its way into a production system, bypassing whatever formal code review processes you might have. And most software development organizations don't have a lot of code review, that bypass other types of checks and balances that you have to try to guarantee better quality code, that pretend to be one piece of software but are actually different. How many of you have heard about SolarWinds? So the SolarWinds hack happened when a widely used, actually commercial piece of software package was pulled into the development tool chains of a large number of organizations and got fanned out and implemented in many different places. And so these kind of vulnerabilities are new, frankly. They're things that people didn't think would be problems before, but we're kind of waking up and realizing that the supply chain has had these vulnerabilities. Now, this was something we realized in the wake of SolarWinds, in the wake of the Heartbleed attack on OpenSSL, and we knew kind of in the open source community we should try to fix this. But this 4-alarm fire happened in December of 2021 called the Log4Shell vulnerability. And I won't go into depth on the timeline. By the way, this deck, happy to share it with you all. This is about 2 hours worth of content I'm going to try to get through in about 25 minutes, so apologies for that. But there was a sequence that went from basically a researcher at Alibaba discovering a vulnerability in the Log4j package, appropriately reporting it to Apache, it kind of leaking early, and it turning out there are actually 4 different vulnerabilities that were pretty severe, all the way from November 24th when that vulnerability was discovered to early January, where you have governments of the world telling people, like, replace this now because national infrastructure is at stake. Like, this very short window from the time from individual discovering this to this becoming a kind of a disaster in the making. So and this is just a reflection of how tightly integrated our world is, how pervasive open source code is, how surprising it was to many people that something like Log4j, like a logging package, that even a small mistake, a simple mistake, frankly, could have these kinds of massive ramifications on everything from the Apple iTunes store all the way to the badging systems that had Log4j in them, right? Like it's this pervasiveness it caught a lot of people by surprise. And it raised some serious questions. Is open source software, which has, up to that point had a relatively good reputation for security, was it actually well deserved? Does this demonstrate deep and pervasive technical issues, perhaps, with how we consume and develop open source code? And do these issues extend to the sustainability model of open source itself? Like, can we really depend upon so many volunteers, and what does that word really mean? We kind of did this preposterous thing where we demonstrated a completely different economic model for how to build intellectual property that flew in the face of traditional assumptions about value creation and wealth creation in the software world. And it was logical to go, is this the price that we all had to pay in order to be, to make it really easy and cheap to use all this code that we all just could give away to the world? Well, And this started to attract the attention of not just the companies and banks and others whose IT teams had their winter holiday breaks ruined, but you also started to see groups, folks like the White House and the National Security Council, the Federal Trade Commission, the UK's National Center for Cybersecurity, many other government agencies start to ask these kinds of questions of the open source community. Now, there was a report issued after about 6 months later by something called the Cyber Safety Review Board, which was convened by the White House to go and study what were the factors that led to Log4j, and then what made the remediation process so expensive. And they basically discovered that, or determined that it was the fact that the developers building Log4j had never been really formally trained in secure coding practices. The software development lifecycle that they used didn't really demonstrate the risk of a whole bunch of code sitting as part of their package that wasn't getting vetted for security, that hadn't been updated in a while. It was a whole bunch of functionality that a small number of people depended upon. And if any of you have written open source code and tried to remove functionality from your package, somebody out there is going to scream, they're going to get angry at you for it, and so your inclination is going to be to leave it in rather than do the appropriate thing, which might be to carve it out. So part of it was they didn't have the right training, part of it was they didn't have any design reviews, third-party code reviews, security audits. They didn't really even have a threat model. I mean, it was really this fundamental thing where we all know as developers, or you all should, don't trust user-contributed input, right? Sanitize it before doing anything useful with it. Most of all, don't parse it for format strings. Now, this might sound like something obscure, but it's really not. And this was what this Log4j was vulnerable to. But they also said that those kinds of resources aren't really available to open source projects largely. The funding to go and do a third-party review is typically beyond the resources available to an individual open source developer. And let me just give a little bit here in the interest of time. Our take is that was not exclusively a supply chain story or a vulnerability disclosure story, but kind of a combination of both. It became a supply chain story partly because of how difficult it was to detect whether people had Log4j running in their infrastructure, and that it was the disclosure process itself, that chaos that emerged, that made it so painful actually for all those teams. And one other thing that I think is really important to get across here, a third-party code review of a package about the size of Log4j wouldn't have cost a lot of money. It would have cost $50,000 to $100,000. And this is something some open source projects are well enough resourced to be able to go out and pay to have happen. On Hyperledger, for example, we've paid for third-party code reviews of Fabric and Bezu and other things. It happens on the Linux kernel project, it happens on the Cloud Native Compute Foundations projects, on Kubernetes, that kind of thing. But many of these projects pull in hundreds to thousands of dependencies underneath, right? And there aren't necessarily the resources to do all of those. So if you could generously say that it would have taken $200,000, counting remediation and a coordinated disclosure process, to actually go and make Log4j a non-issue, right? The log4shell breach. Well, $200K would have been a lot less expensive than all of the costs that were incurred by trying to respond to it. But we're never going to be smart about knowing what is the next Log4j. Like hindsight is perfect, right? But depending on a couple of factors, I could probably generate a list for you of here are the 200 open source projects most likely to be the next Log4j, or with more than a 1% chance of them being the next Log4j. And if I could do that, and if it costs $200,000 times 200 projects, $40 million, well, that's still probably less than the economic impact it had on the world to deal with a Log4j breach. So this kind of calculus says to us, maybe this is the kind of thing that we need to get, not just the kind of coordination that we already see in open source projects around, whether it's companies like an IBM and a Google and a Microsoft and an AWS and a whole long tail of small collaborators working together on code, but maybe it's about pulling together in kind of collective action the kinds of resources that governments can bring to bear, or that industries in critical infrastructure can bring to bear to go and solve some of these problems. Now, maybe we're just happy seeing the world burn. I don't know. I'm not so much. But but instead, I think this is really the point for why we formed the OpenSSF, is this recognition that there's collective action we can take to improve the way that open source code is written, to educate developers about better approaches to take, to work on software and standards that might help harden the software supply chain, but also to look at how do we measure risk in the first place, right? How do we find the next Log4j, or the ones that have the possibility of being that? Or simply, for an organization that deploys lots of open source code, how might you build a risk dashboard that would show you, here's the stuff that's pretty well vetted, you know, like the Linux kernel, right? Here's the stuff that has one developer behind it, who is doing this in their spare time, who cuts a new release maybe once every 6 months, who seems to take about 6 months to respond to bug reports, you know, and who doesn't do fuzz testing or any of the kinds of things that you see from a mature and security-oriented open source project. Like, how do we paint this picture of risk? And if we can measure that risk around open source code and build tools to bring that risk down systematically, then we can make it easier to not only find the next Log4j, but find the other things that can provide risk and vulnerabilities and really make this infrastructure we're building on as, you know, sometimes it feels like Swiss cheese, right? Like, how do we make it actually the kind of, you know, for people to have as much confidence as they have, you know, driving through a tunnel that goes under the bay like we have here, right? You trust that the tunnel's not going to collapse, you know, not even once every 1,000 days or something like that. So the OpenSSF started life, again, before Log4j, pulling together a lot of very disparate kind of angles on this problem, right? Because it really is pretty broad, the number of different ways in which open source software could be improved to improve the security picture. One of those was simply focusing on best practices, and I'll talk a bunch about the examples here, but ways to help developers understand how might I make my code more secure. So we have these working groups, right? One of them on best practices, one of them on trying to identify new security threats in the first place. How do we systematically scan open source code to find vulnerabilities that have been found and fixed in one project, but probably exist in others because they're similar, right? How do we look at how vulnerabilities are disclosed? And that whole process of going from that researcher at Alibaba to trying to get the world fixed, like, what are those steps, and how do we make the cost of those steps simpler and make it more rapid for people to pick up improvements and bug fixes and integrate them into their stack? How do we think about the supply chain? So we have a working group on the supply chain integrity, which is about provenance traceability of code, which is about checking signatures on software artifacts as they flow, which is about trying to distinguish between the stuff that's built in a high security, low risk way versus the stuff that is a little more cutting edge, right? How might we go and ask, you know, projects out there like the Python Software Foundation or the Rust Foundation or the Apache Foundation? What are the security practices that they've developed? How do they manage risk in their own communities? What are the development tools that they use? And so the Securing Critical Projects Working Group is focused on how do we identify those and then systematically build this security capacity across the other major foundations in the world. Lots more that I'll get into, and I'll get into some specifics. But part of this is asking not just what are the interesting projects that might push the envelope on this, but how do we make them the new default? How do we make it so that these are really picked up by the industry, the open source community as a whole, and not just remain interesting thought experiments or demos, right? So let me take this from the point of view of all of you, take this from the perspective of if you're a software developer, if you consume open source code, perhaps you even are submitting bug fixes or feature improvements. Perhaps you even have like a library of yours you put up on GitHub. Here are some tools that you can use to go and be, that are examples of things that we've developed at the OpenSSF. So one of the first is we've developed a concise guide for evaluating open source software. Like, if you're gonna bring it into your organization or into your project in the first place, here's a one-page checklist of things to consider as you're trying to build this picture of what I'm using, risky or not, right? And this is a human-driven process. And again, happy to share this deck with all of you. I won't go through the specifics, but these are questions to ask about the code. Very kind of qualitative, right? The flip side of that is if you're a developer of open source code, what are some specific things you can do to to increase the security and the integrity of your project, and to decrease the prospect of there being undiscovered vulnerabilities in that code, and also to telegraph that to your users, that you take security seriously, not just because you claim to, or because you think you're the best developer in the world, but that you've actually implemented some processes to help with that. We've also developed a course that is about 15 to 18 hours worth of content that cover the 15 to 20 major kinds of vulnerabilities, or mistake, let me put it this way, 15 to 20 major kinds of mistakes that developers make when they write software, especially if they're earlier in their career, that tend to lead to vulnerabilities, right? Things like trusting user contributed input. And how do you avoid those mistakes, right? What are some patterns to not doing that? So we developed courseware, we put it up on the Linux Foundation's training portal. We've also syndicated this out using a standard called SCORM so that companies can integrate this into their own training portals for their own employees. This is the kind of course that, frankly, anybody who calls himself a software engineer, certainly, but even a software developer, should take this course and certify against it. You can get a badge that you can put on LinkedIn that shows that you've taken the course, taken an exam related to it. It's pretty simple, but this is like table stakes. So often vulnerabilities end up being from really simple things. Another one of the tech tools that we've developed is something called the Best Practices Badge. And this is like a checklist. It's kind of like that guide to securing your project, but this is now a list of about 100 different things that you, as an open source project, can do. Do you have a security team? Do you have a vulnerability disclosure process? Do you have you implemented these things, which doesn't guarantee that you have no bugs or no security holes, but at the very least shows that you've taken the extra step to be proactive about trying to manage that. And then you can submit this score, this checklist, your score against it, to a website. Thousands of projects have done this already. It allows people to see, are you scoring high or just kind of barely passing, gold, silver, bronze, as well as like a percent completion, and then allow you to kind of have this race to the top kind of phenomenon go on, where projects, will sometimes, organizations like, the Python Foundation or the Cloud Native Compute Foundation actually did this recently, will start to require their projects to get a minimum score above a certain amount to implement this. In fact, there's a more automated tool called the Security Scorecards that goes and systematically can scan a GitHub repository looking for signs, again, that software projects take security seriously. Looking for examples of things like fuzzing tools being called in by build scripts and test scripts. Now, it doesn't prove that the developers look at the output of those fuzz tools or and use that to fix bugs, but it's a sign, right? And if you get enough of these heuristics, you can start to paint a picture that is kind of like your credit score, right? And your credit worthiness comes from these signals that you send, by paying off your credit card each month and that kind of thing. This is a similar kind of thing for software projects, right? And these checks have been validated by a study that looked at, the kind of checks that the security scorecards work actually implement. Can they be proven to be effective by looking at the projects that have been scanned? By the way, we've scanned over 1 million repositories with this toolkit, and we're setting up mechanisms to automate that scanning on a recurrent basis so that projects can, implement things and see their score go up progressively. And so Sonatype did a review of, they track a lot of software vulnerabilities and have built a big database of when those have hit different open source projects, and they found that the projects that scored better on scorecards had fewer vulnerabilities. And in fact, there were some of those tests that were much more indicative and correlated to higher quality than others. So that was pretty cool to see. Moving on, so that's all about measuring risk, right? How do we talk about actually trying to securitize and harden the software supply chain? So one of, actually our biggest project coming out of OpenSSF is something called SigStore. Now SigStore is software. It's a toolkit for being able to sign digital signatures, sign digitally your software releases. That is an incredibly useful tool as those software components are pulled into other people's build packages. You can systematically verify those signatures and make sure that the end result, even if it's comprised of things that go, 4 or 5 levels back or more, that there's integrity through that chain. What's different about this though, compared to using GPG for those signatures, which some projects do, is that it's a short-lived key. It's very much like the approach that Let's Encrypt took to making it automated and easy to get new TLS certificates for a website. And it uses a distributed ledger to record the signatures so that it's easy to validate. Yeah, this was adequately signed by somebody who actually did represent the developers behind the project. So there are now provably secure, or provenance-tracked system images being developed by the Cloud Native Compute Foundation, which can show all of these underlying components and the releases themselves have been signed digitally. And it just gives a higher degree of trust and integrity that the parts came from where they intended. I won't go into detail on how it works, but a lot of this content is up SIG-Store. This is kind of a home run for us, and it's something we really think every software project should start to implement and digitally sign their releases using. I've got a couple of other things that kind of speak to this as well. Something called Salsa, which is for implementing, it's basically a metadata tracking system for provenance and kind of build quality across a software supply chain. Some of you who've had to implement perhaps the NIST cybersecurity framework understand that being able to tag those releases and tag with kind of the degree of care that you took in the build of the software component is a critical part of meeting certain regulatory requirements and company standards for security and integrity. So Salsa is a system for doing that. Supply chain levels for software artifacts is what it stands for. And then back to content. We've developed a guide to coordinated vulnerability disclosures for open source projects. So the next time a Log4j hits, what we hope is that the developers who realize they've got like a big problem on their hands have use this guide to better understand who to work with and how, so that it can go from this kind of thing that if everybody found out about tomorrow would be highly disruptive, instead work with the major users, work with the distribution platforms, work with security experts to kind of stage the rollout so that really before anyone knows how important that vulnerability is, the most widespread and all of the packages are in place so people can quickly update when it gets published as a 0-day. And we think these pieces really do need to come together under one pane of glass, so to speak. So we're developing something now called the Risk Dashboard that is about taking all these different metrics and putting them into a picture that says, for this open source project, here's all the different ways to visualize risk around it. And not only use that as a way to help bend the people using open source software towards more secure alternatives. I mean, right now, all of you probably base your decision on which packages to use on how many GitHub stars does this project have, or how vibrant does the community look, which is not an unreasonable basis, but imagine being able to take these different bits of data that we've collected and have a picture for that. And our hope is that it weaves its way into developer tools and CI/CD systems and risk dashboards and other things, and from other vendors to basically show that we can bend the industry towards in a better direction, and also bend those projects themselves into adopting some of the practices we think will lead to things to real improvements. Another example of trying to address open source software security at scale is a project underneath the OpenSSF but independently funded. Called Alpha Omega. And Alpha Omega is kind of two good ideas in one, like a peanut butter and jelly sandwich. And I'm not quite sure exactly why these two were put together, but they do kind of fit. One of them is about trying to help build a capacity inside of the major open source foundations around better security practices, right? Around having a security team, around having contribution policies, around doing third-party code reviews. Well, some of this costs money, right? In a way that most other ways that open source works can kind of be done voluntarily, and if it doesn't happen, that's okay. For good security practices, you really do need somebody who's convening your security response team. Somebody who, you really do need to pay for third-party audits. You really need to have some of the supportive infrastructure. And so we've made grants to a number of different foundations: Python, Rust, Eclipse, jQuery, Node.js. And these are going to be multi-year grants with the idea that eventually the stakeholders in those ecosystems fund that work themselves. Because there's an awful lot of projects who will spend $500,000 a year on marketing on, you know, t-shirts and stickers and things like that, which is cool and great and important to do. But we think those projects should spend at least as much on the security of their platforms and infrastructure. And they just need a little bit of a nudge to help them see the value of doing that. So that's one half of what Alpha Omega does. The other half is to set up a scanning infrastructure to go and find new vulnerabilities in open source code. And focus not on like novel kind of like, you know, new kinds of attacks, but instead to say, hey, there's an attack that exploited how zip files work and could inadvertently overwrite, you know, your root directory if you run it as root. Well, that vulnerability exists in thousands of other open source packages. So can we systematically scan for these, find those, and not just report them, but possibly automate the bug fix process so that we're submitting pull requests rather than just problem reports, right? And so that's based on work that's been done by a couple of researchers who we brought on board as full-time employees to help us go and build out that kind of infrastructure to go and close up these issues at the scale of thousands and thousands at a time. And this is relevant because there's as an example of what's possible here, another company did a similar project, a company called Trellix, where they discovered this zip file vulnerability used in 61,000 open source projects, in which they submitted, you know, bug reports to. They didn't submit the pull request, I don't think. They submitted the bug report to, and got about 1,000 projects to actually take that seriously and close up the issue, which means there's still 60,000 vulnerable GitHub repos out there that with this bug that hasn't been closed, but it's been reported against them. So it brings up a lot of issues that are related to this, but we think a systematic approach to this can actually make things a lot better. I'm going to try to speed through this because this is really just intended to be an overview, but partly in response to Log4Shell, we have a lot of pieces of a solution. But when the White House called us and said, you know, is this the new normal, right? These kinds of bugs, and is there an approach that actually tries to solve for this, not just has some interesting ideas, but actually closes these issues? They said, what would it take financially, right? If it cost billions of dollars when something like this hit, and lost productivity, and systems being down, and people's vacations being ruined, like, what would be the cost of actually trying to drain more risk out of the open source ecosystem? And we said, well, there's a bunch of things we could pull together. Let us come back to you with a plan. And so we developed something called the Open Source Mobilization Plan, Software Security Mobilization Plan, which was basically 10 different, call them business plans, if you will, call them prototype, minimum viable project kinds of things, where we might take, you know, resources here to go fund these third-party audits, to go really get SigStore adopted everywhere, to go and do better scanning across all these different platforms. In fact, and I'll talk about some of those details in a bit, but it was kind of given as a, imagine money's always an object, but imagine you had enough to go and actually close these issues. What would it cost? We went to our community, we developed 10 different work teams, we came up with different answers to that plan. The net result of it was $150 million. Now that might sound over 2 years to get this stuff started, to start having real meaningful impact on the order, and it's hard to estimate this stuff. None of us are actuarials, but you know, if you could save just one less Log4j, that would probably still be, you know, make that a really wise investment, right? Now it might sound like a lot of money, but another number that we know that we could compare it to is the $700 million that the Federal Trade Commission levied on Equifax in 2017 for having not updated Apache struts and being vulnerable to that. And so, like, if we could have an impact like that, or an impact to have one less incident like that, or one less Log4j, I think it probably would be worth it. So I'm going to skip through here. Again, this plan is on our website. It's kind of a more like a true north. Like, here's what's possible, right? But all these other efforts that we're doing at OpenSSF feed into that. And there's a few new ones there as well, and we're working now on getting those funded. But it represents kind of an ambitious kind of direction for where we head in the future. In the meanwhile, we really know that it's between measurement of risk, between education of developers and on how to avoid some of those bugs, in the development of new tools like SigStore and Salsa, all of that needs to work together in concert. It needs to be supported by not just the major, tools vendors and cloud providers and kind of the distribution points. It needs to be supported by the open source projects themselves are important levers to get this implemented. It needs to be supported by the end user communities, the financial services communities, the critical infrastructure types of companies out there, but also by governments. There's an important role that government plays as the insurer of last resort, so to speak. When the world falls apart, they're the ones to try to make people whole or as close to whole as they can. They also are tremendous users of open source code, right? And simply to make their use more secure and to try to systematically help, even just for their own sake, right? Turns out they can invest in a way that makes open source safer for everybody. So that's why we're here. We're here to kind of provide these point solutions, but then really chart a path to how we as a whole open source community and frankly as a global community can work together to drain risk out of the system and make open source trustworthy and really live up to this reputation that it's developed over the last 20 years. And with that, I'll pass the mic.
So any questions while you're going to set up? Harris is going to speak next. We've got two quick talks, one from Harris on software supply chain, and then we're going to have the salsa from Ken. So and after this we'll have some more Q&A and then we'll do a group photograph. It's always good to have. So any questions for Brian?
Yes. If we use this sort of scorecard measurement and then we get hacked, what sort of legal liabilities can we waive off?
So this is an interesting point. The open source world has been able to grow and thrive and be innovative, and you've been able to integrate, great work from companies like an IBM or Google or Amazon with, a student hack, over a weekend, because we've built in all of our open source licenses a waiver on warranty and liability. It's up to you as the end user to decide, is this suitable for use, right? Now, end users often don't have the resources themselves to measure that risk. So providing tools to measure risk, again, themselves provided used at your own risk, is helpful. It's not always going to be the answer. If you want to be insulated from risk, you want to buy insurance. Or you want to have somebody else run the software and offer to you as a managed service, right? So it turns out that means there's a gigantic industry around providing these kinds of services around open source code, right? In fact, one might even say maybe there's such a big industry we don't actually want to reduce risk in open source because we want these big companies to be able to build a sustainable model. But this is where every organization that sells support agreements can really play a role in assuming that liability, assuming that risk. But we need to protect that essential social contract between open source developer and open source user. Otherwise, you're going to see open source development slow down, companies be less likely to publish open source code, be less likely to update the code frequently, which is what we need in order to actually be secure. So, and this is less of an issue here in Asia, as far as I know, a little bit more in the US, a lot more in Europe, where they want to try to regulate open source like a product, like a toaster, right? If you buy a toaster and it catches on fire, you're right to have a case against a manufacturer, right? But if you use open source code and there's a hole in it, it's kind of on you. So let's think about different structures and ways to answer that without kind of taking apart what makes open source work. That's a good thing to end
So
on.
we'll go to Harris now. We'll have some Q&A at the end as well, right? Okay. Want to go?
Okay, testing. Can you hear me?
Beautiful.
Okay. So as we heard about the today's supply chain security attacks has been increased a lot in the past few years. Especially the Log4j that Brian is already gone through the instance with us. And unluckily, we do have another critical vulnerability for the Spring Forcell. Just right after 1 year, the Log4j event, the vulnerability has been disclosed. So the problem with the supply chain attack is not only on the open source, but also happen in the most popular source control system like GitHub that we are using today, right? So basically, they do also have the attack from the supply chain perspective. They lead all the tokens, the pages with the access to all those GitHub organizations. And also commercial software like SolarWind, they also have another attack it's a critical attack in the supply chain security as well. So we can think about that like, open source, of course, for the in the supply chain attacks is the most sufficient, major contributors, but also their source control systems or your build systems or any commercial software is also a target for this kind of attacks. So let's jump into what is the fundamentals challenges of the software supply chain today. So first of all, the dev practice. I would like to say a bad dev practice, but there is no good or bad, but it will be an insecure dev practice that I would like to mention. Something like for the developer that they may commit their API credentials or any access token together with the code to the source control systems, and it create a potential bridges for getting those access token for the other resources in your supply chain or any production system like the database or the others. And also the next one will be the visibility. So the visibility here is more focused on do you know how much open source project that you are using in your product or in your in-house application today? Or do you have any visibility on what kind of open source vulnerability, critical high or medium low in the commercial software that you're going to purchase? These are all related to the visibility issue. The third one is the vulnerability remediation. So how quickly you can remediate vulnerability when a CVE was disclosed like Log4j or Spring for Shell, and how quickly your product development team can react and provide the patches to your customer to reduce the impact. And also the governance. So basically, just like what Brian mentioned that before, have you used any framework like Sensor or the other framework to govern the usage or how to securely produce the software and how to use the open source security? And also the risk assessment is also another factor that we need to consider, like do you really able to assess the risk on each of the packages or each of the open source component that you're using is good or is secure? And also, are you ever apply the S-bone analysis, no matter for your own self-developed application or for the commercial software that you are going to purchase? So these are all the fundamental challenges that we have today in today's software supply chain security. And for the application security, we need to evolve to address all these challenges today. So first of all, for the open source security, we need to establish a governance and policy to really how to for adopting the open source project in your development. So something like the open source software clearance, are you really understand the license? Are we going through the clearance process before you can use the project? And also, are we able to assess the community risks? For example, use the scorecard that Brian mentioned in OpenSSF to assess the health of the community. How many contributors behind that, and do we have any security concern for that community? And also we need to bring in the concept and perform the SBOM, generate the SBOM for no matter for yourself develop the application, or and perform the SBOM analysis on yourself develop the software and also the commercial software that you are going to purchase them. And also the major one is that you need to have the security and privacy by design in the developer in the mindset. So every time when you start in the design phase of your applications, you have to think about you have to do the threat monitoring, and you have to think about how to enforce those security privacy by design practice throughout the development lifecycle. And then the last one is the critical software. We have to understand and identify what kind of critical software in your supply chain and better secure them, and also enforce the risk evaluation and security assessment before purchase any kind of commercial software or use any kind of OEM software. So this is a reference model that I put together in order to produce a secure software. So basically, as you can see that, firstly, we need to have a good governance framework, just like Salazar that Brian mentioned in his talk. So, and after we have a good framework to govern the entire software development lifecycle, and then we have to also secure our source control management platform, and also secure our build systems. And we do have also a list of the application security tools to help us to increase or improve the visibility of what kind of open source or what kind of software open source component that we have in our project, in our applications, and also it will help us to evaluate and scan for the vulnerabilities over time. So the point is that you need to think about for the developer, yes, when they complete the code, they will go through the checklist. They will go through this bubble of the checklist. Yes, I do the static scan, I do the dynamic scan, and is that enough? So, but how can we enforce? How can we enforce this kind of security checking in your pipeline process today to really enforce them to go through and make sure that they have all the checks. And then and also when they apply using the open source project, how can they make sure that their open source project is also going through this process to do the to scan for the vulnerability. And also this will be a more like the continuous remediation. So by going through this process, you will continuously find the vulnerabilities. And the developers always, their practice will fix the vulnerabilities for themselves, and then only push that to their repository in their organization. But the concept is that in order to improve the open source security, you have to contribute back the remediation, what you fixed on your in the open source packages that you're using, and you should contribute back to the source, to the open source project, to the actual communities. And with this model, this is a reference model on how to produce the security, the secure software. And in order to prepare for the next critical supply chain attacks like Log4j, as Brian mentioned, that we will definitely have the next one. It's time to step back and think about like how to reduce the risk, how to reduce the impact. So we need to start from the governance and framework. We really need to understand and come up with the framework or use any framework existing whether in the OpenSSF or the other industrial standard for producing a secure software. And then we need to increase the visibility by using different kind of tooling and bringing additional new capabilities into your application security portfolio to enable that visibilities. And also we need to continue remediation, how to reduce the time to remediate their vulnerabilities and how to contribute back to the source of their community project. And the last one is enforce security through the make sure that the supply chain is secure. Build systems, from the build systems, source control systems, and ethics system with critical software included in your supply chain, software supply chain. So yeah, so this is a kind of a quick sharing session. Any questions?
Thank you. Next. Okay.
Okay.
Any questions? We asked them to shorten it because we're running out of time, so I appreciate Harris covering that. Thank you for hosting us here today, right?
Yeah.
So Harris actually works in the internal. Explain a little about what your role is in IBM, right? So you work in the global team, right? Working on supply chain.
Yeah. Basically, basically, I'm working in the IBM CISO office in IBM. My major responsibilities is to support and secure all the IBM products and cloud services from a CISO office perspective. I'm not a this is not a customer visible, more like the internal security. Yeah.
So yeah, thank you very much. Thank you. And now we'll hand over to Ken. Yes, another round of applause for Harris. And you heard about salsa, and now we're going to have an expert in salsa talk about it right today. And then we'll do the photograph and more Q&A. I think we've still got more food.
Okay, I hope it come up. Good. So thanks guys for staying, and I will give you two things you can take home today. The first one is the backstory of the salsa, and the second thing is a.
Do you want to introduce yourself first as well?
Sure, I will.
Yeah.
Actually, cool. So Ken here. I lead Greater China security practice for Google Cloud, and previously I was working for AWS. And before that, I was in Australia as an independent consultant for infrastructure and security, etc. So security is very close to my heart, and especially recently working for Google as well. We had lots of great stuff, especially working with OpenSSF. What I want to share today is Salsa. So Salsa is the open source project we put on the internet for you to consume. If you browse slsa.dev, you can see the entire content of Salsa. And for Salsa, it's open sourced by Google, and it's actually something, our own dog food. That's what we call something we use at Google. Bit of the backstory. Now, back in 2009, there was a cyber attack organized by nation states. It's called Operation Aurora, okay? And it was trying to achieve one thing. It was attacking about 25 technology companies in the United States with the intent to steal the source code. And Google was one of the victims. We got hacked in 2009, okay? We were done. It's a very simple tactic. So there was a message sent to one of the engineers saying, hey, this is a photo attachment, is that you? Okay, oh, I'll open up, is that me? And that was the entry point. And that was basically the binary downloaded onto one of the server in our data center, and that was just for the testing purposes at the time. But it quickly spread across our entire footprint and took our entire team probably about 2 or 3 months of time to completely found every bits and pieces that got infected and then purged the whole thing. That's when we turned around saying, hey, this is bad. What are we going to do about this? What can we do to avoid this from happening again? So I know lots of companies on the market talking about zero trust, and Google, we also do zero trust. And I'm going to talk about our opinion of the zero trust, not the only opinion, okay? So zero trust story at Google has 2 parts. The The first part is towards the users. Users can be our consumers, like B2C companies, C part. And also the users or internal employees as well. We call that beyond corporation, beyond corp. And the other part is how we build zero trust into the softwares we give to the people. Google has all the, you already don't know about Google Cloud, Google, you use Gmail, Maps, search, etc. every day. How do we build those software secure to service billions of users every day? So we have another code name for that project called Beyond Prod, production. So in Google, probably you guys know about Kubernetes. It's an open source project from Google. We call it BOG, B-O-R-G in Google. And we also have another project within Google called Binary Authorization for BOG. Okay, essentially, our intent at the beginning was very simple. We're trying to make sure every piece of software we have running in the production, servicing you, me, has the entire chain of provenance back to somebody sitting in Mountain View or somewhere our development center IDE. Do we have confidence everything running in the production, servicing our customers are actually built by our engineers, going through all the checks and balances? That's our simple intent. And then we built binary authorization for BOG. And that was the origin of the salsa. So that's the story you can take home. I'm not gonna bore you with all the things you know already. Why is it important and how is it difficult? But one thing I want to call out is this is a project from Google as well. I was fortunate enough to talk to the product manager behind this website. It's got a depth.dev. So essentially, again, it's our own challenges in Google. We kind of go, hey, how do I know what software, open source software packages we use, what are dependencies, whether they are secure, insecure, etc. So we started building a database, essentially. And as we were going through this journey, kind of go, look, why don't we just make that public for people to use? Why not, right? One thing I want to call out is, we only, as you can tell, there's a number of packages over here. They are, if the entire open source is a universe and what we're doing right now, we're still growing, what we're doing right now, probably it's not even a solar system, okay? It's like tip of the iceberg. We're probably only working at those things that we use today. Most of the people are using today, but it's not the entire thing. We're still growing though to contribute back to this particular project. It's non-for-profit, so we're actually founding this internally for everybody, for ourselves to use it as well. So some of the attacks I talked about just now, SolarWinds, essentially somebody slipped in a malicious update into the authorized, legitimate supply chain. So as an update, everybody who's running SolarWinds gets a malicious update. That's one way to attack it. And code coverage, code carve essentially is a software for you to identify your testing coverage of your code, supposedly for good, right? But it's compromised, becoming a vehicle to infiltrate all the people who are using the software. And I have a lot for sure. I don't have to talk about, like everybody's talking about this, and it ruined people's holidays, so I talked about that. Now, this is again a very familiar diagram. You've probably seen different versions of this diagram tonight with different color schemes. And I have different color scheme here, the Google theme and the Google avatar. But the part is, we're actually given different stages and different codes from A to H. From A to all the way to the H, just before you deploy your software into a virtual machine, a Kubernetes cluster. That's what Salsa was about, to help you to drive the security from there to there. Now, once you drop your software, should that be a binary on a virtual machine, or should that be a container running in Kubernetes or something else? That's something else. I'm not going to do, it's a community meetup, I'm not going to be a salesperson, right? But something we have to help you solve that if you're in Google Cloud. So my focus today will be on the first part of the journey. Now, salsa, call it salsa, is same, pronunciation is the same as the thing you dip your Doritos in. So essentially, we're looking at the three parts of build, we're looking at the source and also dependencies. Very simple to understand, and we just want to make sure everything you're running in production has the entire chain of provenance cryptographically signed, and you know it's gone through all the checks balances you have, back to the IDEs, back to people cutting their code. Okay, that's a very simple intent. Now, to make sure people have a ability to making smaller changes, continuous improvement, we also give SLSA 4 different levels, level 1 to level 4, 4 being the highest level, okay? Very simple to understand. At level 1 SLSA framework, if you go to salsa.dev, it's got all the specifications. How do you can do self-assessment where you're at, right? But it gives you all the specifications, which level you're actually at. So level 1, essentially, you wanted to automate your build. You wanted to at least script your build in the CI, and you wanted to produce provenance at each step of CI. The provenance can be in the form of a hash, maybe, right? So every time you produce a binary, you produce a build container, you probably wanted to give a hash, and the hash is unique. Every time you build new, even the same container, when you build a second time, you should have different hash. Okay, so every build action should be unique. Now, once you move on to level 1 to level 2, what you're trying to do is have version control. It's quite easy if you're in Git, etc. But when in actual exercise, it will take a bit of discipline, not just technology, but also processes as well. Your people will have to work together to realize version control. But also, we wanted to take that first hash you generated in level 1 to be authenticated, okay? Not everybody, any dogs and cats can generate the hash that you trust. We wanted to make sure it's something you can leverage, such as SigStore, okay? Such as if you're using different open source software like Graph.es or Critis, etc., to cryptographically sign those hash that come out on your CI. Now moving towards level 3, you want to have the build to be ephemeral. Okay, essentially, you wanted to have your build agent to be one-off. Every time you build something, once the build job finishes, it should go away. It shouldn't have any footprint. So I used to work with this customer. One of the projects I helped them was to change their Jenkins from virtual machine to the pods running on Kubernetes clusters. When we came into the project, the problem was they kind of go, look, my build's basically slow, people have to queue up for the builds. So kind of go, okay, why don't we get your build agent to spin up every time you have a build onto the pod, run it, it finishes, goes away. And if you have multiple builds, you can spin up as many pods you want, okay? At the time, we were thinking about the scalability and performance, but actually it also gives you security as well, because it doesn't leave any footprint. Every time you build something, it's a new container and it goes away. And level 4 is very difficult to realize. Essentially, this is a very important part. It says all the build inputs dependencies are specific up front with no internet at the build time. That's very, very difficult. I haven't worked in industry for that many years, but one of the customers I happened to work with when I was working for AWS, they didn't buy the cloud, by the way. They were a bank in China, one of the biggest banks in the world in China as well. So that built part, all the dependencies that actually have that into the private JFrog, okay? And all that builds, entire bank actually looking after the JFrog repository, or obviously a cluster of them, to drag all the dependencies, as opposed to going to the internet and drag them. So people were actually downloading dependencies into the JFrog and do that all the checks and balances, etc., and kind of go, look, it's not good to go. You're only allowed to drag dependencies from that particular JFrog. That's very difficult to realize. And also you have the 2 people review processes. You have the pull request. Obviously you have the pull request reviews by your seniors, the pair programming, that kind of processes in place. Now, that's probably a snapshot of all the specifications just by the names. There are actual descriptions, what does it actually mean for each one of the specifications, and how you can move towards from level 1 to level 4, etc. What I want to do, maybe this is too busy and conscious of time, I share the deck with you, you can take photos up to you. So it basically gives you some, again, my opinion, not the only opinion, some of the open source toolings and the commercial toolings that can help you at each stage. The sequence goes from there, dev, supply, when you prepare to build images, and when you actually attach the images you built, and to your CD, drop that container onto your Kubernetes, okay? So essentially, this is one opinion, when you develop your software and you run your software as a container on Kubernetes, you might have a different type of scenarios that you probably run on VMs, but the sequence will be very similar as well. And also, I wanted to bring a very super simplified version of level 3, salsa level 3 example. What does it look like? Okay, coming from very left-hand side, just use GitHub action as an example. It can be any CI that you use, so that GitLab, GitHub, or Jenkins, whatever. So that has to be ephemeral. As talked about, every build needs to be ephemeral. It builds and it goes away, no footprint, okay? And once you build, let's say, your GitHub action, you have all the checks and balances, your static analysis, and all that kind of good stuff. And one thing you can actually do also over there, I've seen one of my customers does, is they build the SIG-store equivalent or anything that can produce the hash as part of your CI script. So you kind of go, look, my CI is going to trigger a static code analysis. Great, okay? After it's done, my CI is going back to the static code analysis to look at the output. You can automatically check kind of go, if my static code analysis says it has high vulnerability, then fail it. If it doesn't have that, proceed to the next step. The next step will be probably building a container, and you can scan the container as well. As you go to all the gates, at the end, you have a container image which you push to your registry. It can be Docker or somewhere else, it's fine. But that particular container image, that particular build version has to be signed, has the hash. And what that means to other people is that particular Docker container went to all the checks balances you built and is assigned indeed by your CI. Also, that's where you can, like this is an example using cosign as well as SIG-store, that's fine. But when you're trying to deploy the container into Kubernetes cluster, the Kubernetes cluster has something called admission control. You can think of admission control is a tab in front of the Kubernetes API. So any commands you're trying to drop container, deploy container, delete container, or do anything, you need to interact with the Kubernetes API. And before the API, that's admission control. That's where you can integrate your policy with admission control. You can write your policy in the form of Rego, Open Policy Agent, or other languages of your choices. So over here, you kind of go, look, I have cosign with a list of the images that I trust, and those are the only images that can run on my Kubernetes cluster. Any other images, you really go like kube control, run, nginx, latest, that's not going to run, okay? Because that particular image doesn't have the hash over there. That's one of the opinions. This is the probably more reference architecture you're using Google. Feel free to take a photo if you like to. But very soon you find out, although I've been putting Google products over there, but you'll find out you can replace them with things you use today. AWS, Azure, they have the same thing as well, so it doesn't really matter. I can share this stack with you after this call as well. So as you can tell, I'll break this thing to 3 parts: build, deploy, and runtime. And also with each of the parts, I have a description. Why does this particular reference architecture can constitute as salsa level 3? And at the end, I also called it out. Oops, stuck. So at the end, I'll also talk about some of the elements around runtime as well, because it's great. You shipped very secure software into the production. Okay, then what? Runtime is also very important. It's all about your operations. Let's say if you're running a software to service a 2C customers like us, Google, and you want to worry about DDoS, that kind of stuff. Also, you want to worry about how do you run security operations. How do you have the visibility and finding new threats, that kind of stuff. So just some framework to provoke your thoughts. I'm not selling the products, obviously you can reach out to me if you want to buy. So I think that's me. I'm on the dot at 7:30. Yeah, open the floor for the questions. Brian, me, and Harris.
Yeah, why don't you all stand up? Thank you. I think we had some, and maybe Boris should stand up as well, right? Boris is the other organizer, right? Who's been organising. He didn't have a chance to speak tonight, otherwise I'm sure you've had some very wise words to say.
I think also, maybe another element is, this is the first meetup.
Yeah.
You tell us, is this content that you like to hear? or what else you want to hear, things you like, you don't like, and your wish list. That can really help us to organize the content for the second meetup as well. Yeah, that'll be very important feedback on you.
We want to see a demo.
Demo, nice, okay.
We want to do a demo workshop.
Demo workshop, okay.
Yes, I think actually
That's fine.
we've kind of had a chat about the fact that this is obviously very high level. Some people like it high level. Some people like to get, I know Kenny likes to get into code. So we'll coordinate, organize stuff separately like that. So I know we had some questions. I think you had a question?
Yeah, I was curious with how Brian works with vendors, competitive vendors like SNCC and so on. I think you have up there that have their own SaaS tool, they have SCA, they have SBOM. Where are you focusing and how do you leverage those competing vendors?
I mean, it turns out open source has had this challenge since the beginning, right? Is when you have open source software that you're developing for a domain that is usually initially pioneered by some of the proprietary vendors, eventually they get through a couple revisions of their product cycle and then realize that the real value lies in a differentiated layer above, and there's a commodity layer that they might as well just divide the cost of, right? So a lot of it is about bringing organizations together, not just the vendor community, but people who might have built their own kind of home-brewed versions of those tools, right? Or researchers or even students starting to build this stuff and go, well, what's the next version of this that we can build together and share the cost of? Well, everybody's able to move on to the next thing, right? So there's not like a specific technique other than lots of conversation, and eventually companies realize like Sneak and Sonatype, because they hear it from their customers. Why do you buy one company's products over the other? It's typically for some value that you can put up here above a line, and the stuff below the line you should collaborate even with your fierce competitors over. So I don't know, it's something that it used to sound like magic or voodoo or like silly hippie thinking 20 years ago, but open source has made that so common now that you see that kind of evolution from proprietary value to open source value, sublimation, right? Taking that phase change taking place over like a short window of time, like a few years. And in some cases, open source software is pioneering new stuff. Stuff will start out in open source, and then the vendors realize their role is, as we talked about before, deploy it for customers, assume liability, make it actually work at scale. But a lot of the core can actually come from an open source project. I think the harder question is how do you manage some of the personality differences, some of the desire to be known as a thought leader in a domain, and I guess one part of my job is trying to find ways for the companies that get involved in OpenSSF to talk about their work, right? To take some credit for, even when they're contributing to something that's shared and giving it away for free, get some benefit from that by hosting a meetup, by talking, about the work where Salsa came from, for example, which is a great story from inside Google about what drove kind of the need for this technology. And finally, a lot of what you're seeing, like Salsa and Sixstore, was developed inside of organizations not because it was a product, but because they had to solve an internal problem. And then they realized everyone else has this problem too. So why not only share this, but hope that those other folks can collaborate, help fix bugs, add features, and get it adopted as a new standard, right? Some of this stuff to really be valuable, you want to push upstream to all the dependencies you're consuming from all the different places that you can. So that's a natural motivation as well to work together.
So when I work in software QA, coverage test was an element that we look at. But from the security point of view, does coverage test meaning anything from this project? And also, are there unit tests or security tests that are available for other developers to take it and then put in our code to automate some of these, let's say the network layer communication tests?
I think a way of answering that is what we actually haven't found anybody show up to the OpenSSF to contribute is software to try to automate scanning of source code. Because that's actually, first off, there's a lot of tools out there that do that, and a lot of them generate low quality output, right? To try to parse and look for new defects in source code, there's a lot of false positives that end up getting generated. So it's hard to say, here's a standard security test that you can apply to look for new vulnerabilities. Instead, looking for signs of that a project takes security seriously is a more dependable way to try to assess that risk. I guess I didn't quite understand the question, but I think that spoke to it. I don't know if anyone else had an answer. Okay.
I think, look, again, this is a community meetup. I'm not going to recommend any products. And very soon you find out some product, vendor will approach you. But one of the challenges when you plug this product into your CI, very simple. It does all the tests you want it to do, and it probably will produce more information alert than you can handle. Okay, so you have to really pick and choose. Again, taking the approach of moving towards up the ladder. So maybe very very simple example. If you use a vendor called a Snyk, okay, you plug into your CI, and very soon Snyk's probably going to give you like hundreds of different layers. And because you can actually see different several layers down the particular package you're actually using directly, and you kind of go, oh, what am I going to do now? What can I do? But don't worry, like it takes a bit of a journey, but tooling out there, more tooling than you can choose. And I think it's about a process of how you leverage what the tooling tells you to do, and that's probably more important as well. That'll be my 2 cents, yeah, I just dropped a product name. I like Snyk, but you know.
We're neutral.
Yeah, we're neutral.
Any other questions, please?
So I've heard about the framework SLSA, and then sometimes we got a software well-known vulnerability, and then we know that we don't have any free for currently, so that it's a SLSA is because we have some handling using infrastructure to block some networking like Log4j from in PVC. We use a firewall to block the traffic before the patch. So is that SLSA support infrastructure to minimize for the intermediary remediation, or only software?
So SLSA is a framework, and at the very beginning, I think I talked about the story. How do we come up with SLSA? It was called a binary authorization for bulk, okay? But also I've seen people using SLSA framework for their infrastructure, but only for the cloud for now, because it's easier for the cloud. Taking one example. You build your entire cloud infrastructure from all the networking, firewalls, etc., using something called infrastructure as code, okay? Such as Terraform. Terraform being infrastructure as code is code, okay? Being code, it can be checked in the Git. And being the Git, it can be orchestrated by CI. Being in the CI, you can write different type of security unit tests, right? So that's how you can actually bring infrastructure world, leveraging SLSA to be able to help you with your infrastructure build security. Now on-prem, it can be a little bit difficult. I know Terraform does have some providers for on-prem technologies. It can be more difficult. But again, SLSA is a framework, it's open. It's up to you how you want to use it. Only intent SLSA has is something you run in a production. Should have a piece of infrastructure, a set of infrastructure or code? Does it have entire chain of components back to the person cutting the code? In between that person cutting the code and something running in production, do you have all the checks and balances in between? So I think that's the only intent you're trying to fulfill. Yeah.
My question is slightly good. So SLSA level 3 reaching out to protecting the infrastructure, right? It's like to the servers running the building and to perform the physical builds. But my question is when I talk to people like like Web3 and the virtual asset regulation is quite a hot topic in Hong Kong this year, and supply chain will be a very serious issue. But the problem is, when we try to build those, like the blockchain stuff, and we are running a bunch of the building infrastructures, and when we look into the SLSA level 3, it's quite vague. It's like when you mention about the system hardening stuff, is say okay, probably most people will come up with a CIS or STIG, and my question will be, will OpenSSF or the SLSA contributor will consider to add in more the defensive technology like confidential computing or the other
like the zero-day mitigations into the SLSA level 3 or level 4 as a minimum requirement, because of that, maybe the regulator might be, to more easier to understand and follow their framework.
I'll take this start and give to Brian. I think the first one is Web3 is so big, right? You have crypto exchanges, they are essentially Web2. My opinion, again, okay, don't take my words. They essentially, any Forex exchange platform will look like a crypto exchange platform. With the differences of probably they have the hot wallet and the cold wallet. Now, the other part of Web3 is like you writing a smart contract you put on the public chain like Ethereum, Solana, that's different. And that's totally disrupted in modern software development lifecycle. You need to really going back to when you're developing software for cars, when you drive the car, the head unit firmwares. Because once you push some smart contract to the chain, you cannot take it down. It's one go or another. So you have to do really thorough testing at the very beginning. You don't get to IGO it. You don't get to, fix it later on. So
I didn't refer the smart contract parts, but only the infrastructure, like the nodes, which is running the Linux system. And you kind of run a Linux system like the build infrastructure, right? And how can you ensure of that the infrastructure has not been compromised? My question is with the OpenSSF to adding more new technology like computation computing to introduce the trusted computing, remote station, and for that as a minimum requirement, because for that it will be more easier to let the user and the regulator to understand what the risk is and what kind of regulation we should perform for the next step.
So the OpenSSF doesn't tell the projects what to build. Like there isn't like a top-down roadmap, it's bottoms up. So the salsa community defines what it wants to build, what it wants to build next, and even on a policy perspective, like would it step into this or that? So in some ways you're even more qualified to answer this question than I am, but just from I think that the main issue, the main point I'd like to get across is, if there are things that you think it should do or an opportunity to improve, the best way to have that is to show up onto the project and talk about the idea, talk about the value that it would create for you. If you want to write something on, on your own kind of channels, your own socials, whatever, to like help explore the idea, that's great, you can point to it. But it's a pretty warm community. It's one that would really, I think, welcome kind of different perspectives on things they should be doing. But the most effective way to see a change happen is a pull request, right? Is code that implements the thing and an idea. I'm not saying they're going to accept every pull request that comes in, but it's the best way to illustrate kind of the value, I think, of what you want. And I have heard people talk about what is the right role for confidential computing, secure enclaves, and that like to play in the in the build processes. There's some interesting tech out there. I'm just blanking on the names of, but I think that's unexplored territory so far, and would be really interesting to see somebody do something connecting salsa to that.
So the foundation goes and helps out all these open source projects and scans them. I'm not sure if you're scanning from CVs or you're just applying general practices. I'm sure you can observe that you can choose both. But then you build a nice database of secure projects and non-secure projects, and then you look at your deps.dev, so you have all your dependencies. So now what I have is an easily accessible and probably cost-effective way to identify targets for attacks. And you ask a tiny little open source project to please fix this, your critical brick in that nice case D, where there are tiny bricks that can collapse the whole tower. What is the kind of vulnerability release protocol? Is there kind of like a researcher ethics involved in the way you announce things, or?
Just to clarify, deps.dev is a Google project,
yes.
Not an OpenSSF one. And the Alpha Omega project, when they do their scanning of I mentioned like the 10,000 top projects, look for new vulnerabilities, right? They certainly won't go out there and say, okay, here's the vulnerabilities we found, push all these 0 days out. they do have a vulnerability disclosure process that they follow that is based off the guide to coordinated vulnerability disclosures built by the best practices working group. And obviously a signal that something might be a vulnerability, there's still a path between that and getting a patch done. You can automate some of the patch generation processes, but it's important that the folks you're submitting this to don't feel like they're just getting like automated notices from a bot, right? Because then they'll ignore it, right? That you find some way to make it clear there's like a human validating that this is an actual issue and something that those upstream projects need to pay attention to. But part of that process, part of that coordinated vulnerability disclosure process does include things like if there's been no response from the project after 90 days, then you do have the right to publish it publicly, right? So that the users, who are vulnerable to this can be informed. So it's a balancing act, but there's a lot of care and thought put into it. And most importantly, in all the stuff that we're talking about here, just because something might be a good idea, you can't presume people will pick it up. You've got to meet developers where they're at with lots of carrots by getting things changed in the defaults so that developers don't really need to lift a finger, hopefully. It's baked into the tooling. And then by the end of that cycle, it becomes kind of like the adoption of TLS on the web, where it took things like Let's Encrypt to make it really easy to go and automate getting updated certificates for your website before you could really introduce penalties for not doing it, right? Which you now have in the major web browsers, right? They get, put up really angry messages if you're trying to access unencrypted websites now. So that's the phase change that we want to try to see with the adoption of these different technologies, and they all have to start with carrots to make it, to make it easier to get this stuff kind of started.
I think we're going to have a wrap here. So thank you, Brian. Thank you very much. Actually, one last question: how does one get involved in OpenSSF? Sorry, I forgot to ask that question, but kind of important.
So obviously the website openssf.org is the first landing spot. There's a link called How to Contribute, which has links to all the different working groups, and Slack is perhaps the easiest, most conversational way to kind of explore a different community. But everything is put up on GitHub, everything's put on Google Docs. We probably use too much of, but we try to be just as completely transparent as we can. And so you come in. I like to think it's a warm community. So come in and ask dumb questions if you want, and you'll find kind of your kind of folks to connect with, or usually through Slack, but email and other tools. So.
And how do you see the meetups kind of forming?
And our hope is that here in Hong Kong, the Meetup community, we could meet once a month, once every other month, and move from giving talks about what's going on in the rest of the world to the role that all of you might play soon in helping push these projects forward. So that'd be great.
Okay.
Thanks.
Thank you.
And now we're going to try to do a photograph. I don't know how we do it, right? How we logistically do this.
Well, what if they stayed there?
Yeah, everyone's
turned around.
Everyone stays seated.
If one person could take a photo,
Yeah.
from up there.
Can you take the? Sure. Yeah, take a photograph.
We'll sit in the front.
Yeah, we'll sit in the front
I have one more.
and smile.
Sure, just give me your phone and then.
Do it in a panorama mode.
I hope mine can wine, Is it?
Well,
Cheese. Okay, this one first, and then we have another one. Okay? Okay, see the camera, 1, 2, 3. Okay, maybe 3 more. Okay.
Ideal.
Okay. Yes, and then HA.
Right. 1, 2, 3, say cheers.
Cheers.
Right. Looks good.
Put it on the meet. Actually, not everyone. Please connect into the meetup. There's somebody who went through LinkedIn. Go on the meetup page and have chats and tell us what you want as a community. Right? This is your community. Thank you.